Alrighty, geometry. Excuse me. It has been one crazy week. I am telling you that right now. Not a picnic. Um, let's just say that I forgot what morning was. Before I begin this lesson, I do want to remind you of and well, tell you, in case you don't know or remember, Study Island. I'm going to do you guys a great big favor, okay? On the Study Island, what I'm going to do sometime this week, I'm hoping I can get to it by Wednesday, which I know right now is Monday. I'm going to reopen all of the Study Island assignments that we've done, which won't take me long. And I'm going to give you till the end of the 9 weeks. Well, starting today, it will be exactly 2 weeks, 2 full weeks. March 18th, I think, is the last day to actually do them, get them complete. Now, I won't give you full credit, but I will give you, I'll use the power of I. I think that's fair because it is a lot of work to go through everybody's sessions and everybody's work and see how we're doing in those. Next 9 weeks, I won't be too forgiving. I am just going to open up a bunch of them and have them do at the end of well, not at the end of the 9 weeks, but probably about the middle of May. I would say that's what I'm going to do. So I may give you 15 total and let you have at it. I'll make it worth one big assignment. So I just want to get that out there before I start this lesson. We're going to continue on. There's a couple questions on the pre-post test that deal with surface area. And I'm going to focus on two particular shapes. To help you guys out with that. Today we're going to talk about cylinders. So let's go ahead and begin. I could mumble on forever and ever. You guys know that. But I just want to go ahead and try to make this video as short as possible. Which is already 3 minutes into the video. And I haven't done anything yet. Well, here is your example. How much paper is needed, okay, to cover? So we're talking about surface area. When you're covering something, it's surface area. The outside of a Quaker Oats box, you know, like the oatmeal. It's got the Pilgrim dude on the front. I usually put more brown sugar and jelly in my oatmeal than there is oatmeal. It's so good, though. Whose height is 11 inches and diameter is 5 inches. Okay, so I'm going to highlight those two things. I'm going to draw a picture. This might look pretty, it might look ugly, and it might be pretty ugly. In my case, it's not the first time it's ever been told. So there's my Quaker Oats oatmeal box, which I'm going to just hold off right there. And I'll outline the diameter. Okay, so let's say the diameter is this straight line here, and the diameter is 5, and the height is 11. Alright, so we need to talk about a couple things. We're covering everything, top, bottom, the side. This could be a Quaker Oat box. This could be a pop can. You know, how much aluminum or aluminium is how they say it in the UK. Is needed to make a pop can. You know, just anything that's cylindrical. Alright? Now let's think about the shapes that are involved. Okay? I'm going to make a list out to the side here. We have 2 circles. And what do we know about these two circles? They are the same. My stylus is going crazy. Hang on. They are the same size. Okay, that's good to know. Alright? And we're talking about surface area. And surface area is basically, by definition, the area of every side of a three-dimensional shape totaled together, all summed up. Okay? So if we find this side area, we find that side area, we find all these areas of this three-dimensional shape, and we add them together, that is surface area. Okay? So, just like you're painting in a house. Okay? If we want to know how much paint is needed to paint a room, the four walls, yeah, it would be easy to find the area of each wall. But when you add all four of those walls together, see how much total paint you need, that's surface area. You're just excluding the floor and the ceiling. I would feel bad for you if you were painting the floor and put carpet on the ceiling. I wouldn't put it past you guys. Anyway, so let's kind of come up with some basic surface area of a cylinder kind of formula here. You can look them up. You can see how they're used. To me, I like to see how they were designed. Alright, so let's go ahead and start that. Now we know the two circles, top and bottom. Okay, that's this part here and this part down here. They're the same size. So in theory, if I find the area of one circle and I times that by 2, I should get the area of the top and the bottom. Now let me go ahead and find the area of one circle here. Okay, so we got 3.14 times the radius. Now the radius is actually half the diameter, which is 2.5. Alright, now I'll go ahead and calculate that part out. 3.14 times, I'm using my online graphing calculator. Oops. And I just, I need to start over here. Hang on. 3.14 times, give me a second. I know you probably already got it punched in. Good for you. It's about time you did something right. And I'm going to hit enter, and I get 19.625. Now, if I times that by 2, I got the area of both circles already added together. So let's times that by 2. It might be 40 something. 39.25. Okay, I was close. So the surface area of the top and the bottom put together is 39.25 inches square. Now, since we're talking about surface area, we're talking about square dimensions, okay? Not cubic. We're not filling this up. We're taking a 3D shape and we're finding the two-dimensional space that's needed to cover something. It's different to cover something than it is to fill something up. So I'm going to write that here. 39.25 inches square for both circles. Okay, that's the area of both circles, two circles. Oh, my stylus is killing me. Sorry. Now we need to find the other part, okay? The side. Now, if I cut down the side, what kind of shape would I have? Well, let's say I cut a line through here and I unfolded it. Well, I would get a nice rectangle. And you know that from junior high and hopefully 4th through 6th grade and maybe 3rd. But keep in mind that we got the height is right here. A lot of people have trouble figuring out what that is. Okay? That length is actually the circumference of a circle. Now I'm going to draw this on a separate page here. I'm going to draw that rectangle up. Actually, I'm going to do a better job here. There's the rectangle. That's a rectangle. Let's figure out how to find this length and then how to find the area of it. Well, that length is the circumference of a circle. Now, the circumference of a circle is 2 pi r. That is that length. And I know the radius. Okay, the radius is 2.5. So if I actually plug that in into this expression, okay, that gives me 2 times 3.14 times my radius, which is 2.5, I believe. Right? Yes. That will calculate my length. Okay, so let's calculate the length here. 2 times, oh my goodness. Oh my goodness. Having all kinds of issues. 2 times 3.14 times 2.5, enter. Alright, so that length is, I got 15.7. If you guys punch it in, you get something different. Shame on me. Now we got to find the area of this rectangle. Well, every rectangle is length times width. Now this is usually considered to be the length, and the height is actually considered to be the width. In this case, alongside the length. So to find the area, I'm going to multiply this 11 and 15.7 together, and that will give me the total area, which is, of this rectangle, 172.7 inches squared. Now let's go back to the very first part of the problem, 172.7 inches squared. Now to find the total surface area, and you can write S period A for surface area, and add those two things up. So I'm going to take 39.25 plus 172.7. Sorry. And I get 211.95 inches squared. That's how much paper would be needed to cover the Quaker Oat box. Now let's recap and come up with the formulas. Okay? We found the area of two circles. We know they're the same size. Okay? So basically I did 2 pi r squared. Right? That's what I had here. I'm going to put 2 right here. So in my formula I got 2. This is for, let me write this out properly. Surface area. And this is what you're going to be using the whole day. Surface area of a cylinder. Oh my goodness, come on. So we got 2 pi r squared. And we added what to it? Well, here's the height. That's h. And then here's this 2 pi r. So what I added was the 2 pi r h. Now, if you know the radius and you know the height of a cylinder, you plug and chug that into the formula. That'll give you the total surface area. Now, I want to make it even easier. I want to factor what these guys have in common. And here's what you end up with. They both have 2 pi and a radius. One has radius squared, one has radius. Let's do this. 2 pi r times. I took care of that, took care of that. I only took one of these. That means there's one left. Okay? I'm just using some basic algebra to factor. Plus, I factored the 2, I factored the pi, I factored the r. All I have is h. So this would be the formula. That's even easier than the other formula. You know, this is the kind of the classic formula. This guy right here is the Seidel formula. Okay? Both will give you the same answer. Hopefully that helps you out. Wednesday we will talk about surface area of pyramids. I will have a video ready for that by Wednesday. Okay? So, till then, be good and keep up with the study island. Later.